Hey guys, it's Booth Dog again. Hope you're all doing well. I know this is definitely going to be an adjustment for everybody, so just know that I am here if you need absolutely anything. Now, Mr. Boothman's going to deliver some lessons very shortly. Why don't we bring him on camera now? All right, Mr. Boothman here. Let's get started. All right, let's go ahead and get started with section 7.2. 7.2 is all about what we call unit vectors. Okay, so what do we mean by unit vector? Okay, well, where else do we use the word unit in any of our studies? Hopefully you're thinking of the unit circle. And we call the unit circle because it has a radius of 1. Okay, so this word unit tends to talk about 1, a value of 1, something that's at its most basic. Because we can build all of our other numbers, all of our other values from this unit. Okay, so a unit vector is any vector with a length of 1. Okay, there's our first blank right there. And as you might imagine, most vectors are not unit vectors, okay? But we can still find one of the most common questions that we'll see with our unit vectors is finding a unit vector that goes in the same direction as another vector. Again, why is a unit vector important? We can use it to build up any other vector. So we're often interested in finding this unit vector that's going in a specific direction to make working with a more difficult vector easier. So how can we do this? Well, if we have any vector v and the magnitude of this vector does not equal 1, okay, in other words, it does not have a length of 1, so it's not a unit vector, then we can define a unit vector u for vector v if the magnitude of this new vector u equals 1 and vector u has the same direction as vector v. Okay, so that's what's going right here in your notes. The magnitude of vector u equals 1, and it's going in the same direction as this other vector. Okay. Let's look at some examples now. Example 1, consider the vector v equals 3, 4. Find a unit vector that has the same direction as vector v. Okay. Well, it's going to be a little tricky here, but hopefully you can follow along with what I'm about to do. What is the magnitude of this vector? The magnitude of vector v, if we recall from yesterday, it's from the Pythagorean theorem, the square root of 3 squared plus 4 squared. Square root of 9 plus 16, that's the square root of 25, which is 5. So we know that the magnitude of this vector is 5. We want a unit vector. In other words, we want some vector that has a magnitude of 1. So how can we take this magnitude of 5, how can we take this vector with a magnitude of 5 and turn it into a magnitude of 1? What can we do to turn anything into 1? We divide by itself. So we're going to have a unit vector in the same direction as this vector, but I'm going to take this entire vector and divide it by this magnitude. Again, why? Well, 5 divided by 5 is 1. So I'm preserving the direction this vector originally had, but now I've forced its magnitude to be 1. Okay, so what did we do here? We divided by the magnitude of v to force it to have a magnitude of 1. And in general, that's what we're going to do for all of these questions, okay? If we want to find a vector in the same direction as another vector, but with a magnitude of 1, we're just going to find its original magnitude and divide by that magnitude. So looking at example 2, we have the vector u equals 5, negative 6. Find a unit vector that is in the same direction as vector u. Well, the magnitude of this vector is given by this formula, 25 plus 36 to the square root of 61. This does not simplify, unfortunately, but the magnitude of this vector is the square root of 61. So if I want to take this magnitude and turn it into 1, I'm going to divide by the square root of 61. So our unit vector equals 5 over the square root of 61 and negative 6 over the square root of 61. And that's it. Now, of course, you can rationalize the denominator here. You don't have to. We've talked before about rationalizing denominators. But that's really all there is to these problems. Okay, so I would like you to do example 3 on your own. Check your answer with the guided notes that are on Google Classroom. Okay. That's really it for this learning target, this first one, finding a unit vector with the same direction as another vector. Okay. So instead, I do want to move on to the second learning target here. Like section 7.1, this section is pretty straightforward, so I'm kind of speeding through it. Hopefully you're okay with that. Let's talk about 2 special unit vectors. Okay. Vector I, which is the vector 1, 0, and vector j, which is the vector 0, 1. Now, it's just by convention that we call these 2 vectors I and j. Both of these vectors have a magnitude of 1. You can check that yourself. 1 squared plus 0 squared, square root, equals 1. But any other vector, think of literally any other vector. If we have the vector 3, 4, we can define this vector, we can express this vector in terms of multiples of I and multiples of j. Again, if we're thinking of a vector as displacement, as a measure of how much we've moved from one position to another, then we've moved 3 to the right, in other words, 3i, and then we move up 4, in other words, 4j. I has a horizontal component of 1, j has a vertical component of 1. And so we can use these 2 special unit vectors to build up any other vector we want. In fact, often we will express vectors instead of our pointed brackets, our angle brackets, a, b. We can express this in terms of I and j, in terms of multiples of I and j. So if we're moving a in the horizontal direction, then we are taking a multiples of vector I, and we're adding it to b multiples of vector j. Let's look at some examples. Write the vector u equals 5, negative 8 in terms of I and j. Well, what is a? And what is j? I'm sorry, b. That's it. That's literally all we need to do. Okay, so we can express vectors in both of these different notations. They give us the same information. We're just using these 2 unit vectors to simplify some of our calculations. Looking at example 5 then, if u equals 3i plus 2j and v equals negative I plus 6j, okay, write 2u plus 5v in terms of I and j. Okay, so it's the same addition, it's the same multiplication that we had before. 2u is going to be 6i plus 4j, and 5v is going to be negative 5i plus 30j. And if we want to add these 2 together, then we're adding our horizontal components. 6i minus 5i is I, and then we're adding our vertical components. 4j plus 30j is 34j. As long as we're keeping our like terms together, we're taking our time, it shouldn't be terribly confusing. Okay. And I would like you to do example 6 on your own. Okay, very similar to what we just did. Notice we're also being asked to find the magnitude of vector u. Okay, this is still a, this is still b. So magnitude is still going to be the square root of a squared plus b squared. And feel free to check your answers with the guided notes on Google Classroom. All right, I also have some built-in extra practice problems here for what we just discussed. Okay, so this PowerPoint will be posted along with answer slides in here. So before you take today's exit ticket, work through the problems that I just skipped over in the guided notes, work through some of these practice problems in this PowerPoint, check your answers, ask me any questions you have during the Q&A time today, and then you should be ready for your exit ticket. Now, there is one other piece to 7.2, and it's pretty interesting, at least I think so. What if we know the magnitude and direction of a vector? Okay, so I know that the vector has a length of 5, and it's going in, let's say, this direction. But we don't know its components. So I do not know its horizontal and vertical components. Is there a way for us to find those components? Hopefully you recognize that this right here is something we have drawn multiple times so far this year. In fact, this semester alone. We know the direction of this vector. In other words, we know this angle. Can we find A and B? We can. Instead of calling this 5, I'm going to generalize this and just refer to it as the magnitude of vector v. Then cosine of our angle is adjacent over hypotenuse. So A equals the magnitude times the cosine of our angle. Sine of theta is opposite over hypotenuse. So our vertical component, B, is the magnitude times the sine of our angle. This right here, this magnitude of vector v, it's the same thing that we've been calling r. We've called it absolute value. We've called it magnitude. We've called it distance. We've called it the hypotenuse of this triangle. We've called it the modulus when we were talking about complex numbers. This same value has multiple names in multiple situations, but it's the same thing. These formulas are formulas we've used. We've just had different variables there. Okay. So if we want to find vertical and horizontal components, A equals this. This is our horizontal component. And B equals this. And this is our vertical component. And that just comes right there from the triangle. Finding A and B allows us to write our vector in terms of I and J. One other note I'd like to make about this unit vector I, this is not the same thing as our imaginary number I. There is a reason we write that imaginary number a little more curved, okay, to distinguish it from times we use I in any other context in math. Okay, so just please note, those are not the same thing. Do not use the curved I to talk about this unit vector. Let's look at a couple more examples, and then we'll be done for today. A vector v has length 8 and direction 60 degrees. Well, its length is 8, that means its magnitude is 8, and it has a direction of 60 degrees. Okay, another way of expressing direction is theta. Find the vertical and horizontal components and write v in terms of I and j. We want A, we want B. A is given by this formula, B is given by this formula. And now all we do is plug in. The cosine of 60 degrees, you need to know by now. And the sine of 60 degrees, square root of 3 over 2, simplify. And so to finish expressing this vector in terms of I and j, vector v equals 4I plus 4 square root of 3j. In other words, from wherever we're starting with this vector, remember it doesn't have to be the origin, in this case it is, over 4, and then up 4 times the square root of 3. Okay, so it's going to be a little more. So this should have a direction of 60 degrees and a length of 8. There we are. So I'm going to have you do a couple more practice problems after this. We do have one more example in these notes to take care of. Pause this if you need to finish getting this down. Go back to any parts that may have confused you. Very last question, find the direction of the vector u equals negative square root of 3I plus j. Find the direction. So if we're asked to find direction, then we're looking for theta. We have A, and we do have B. B in this case is just 1. Now if we think back to the last few units, finding theta given A and B given x and y is using this formula. Tangent of theta equals y over x, b over a. Tangent, we're going to need to use the inverse tangent. Hopefully you still remember that this needs to be unsimplified. We end up with this fraction. Where does this occur on the unit circle? 5 pi over 6. So the direction of this vector is 5 pi over 6. Again, a few more practice problems for you. Go ahead and work through them. The answers will be included in this PowerPoint. Once you're done with that, you've asked me any questions you have, please take this exit ticket. Again, it will be a Google form, graded just like normal. That will be due by the end of today. And we'll begin 7.3 tomorrow. So please, please, please take this seriously, take your time, go through this, rewatch any parts that were confusing to you. Feel free to ask me any questions you may have. Okay. I'm sure I'll see many of you during that time. Nadia, stop panicking. You can come ask me your questions, and we'll go from there. All right, see you guys tomorrow. All right, well, that's it for today. Hopefully, you're starting to get into some sort of a routine. Again, let me know if you have any questions or concerns. Email me, Google Meet during our Q&A time. Anything you need, I'm here for you. All right, have a good one. And make sure to hit that like and subscribe button on your way out.